For this quiz, we need to find the Laplace transform of this equation right here. F of t is equal to 31 t cubed, and then we have e negative 5t ut. Well, for our t cubed, we are going to use this to find the Laplace transform of it. Now, we can say that this is f of s, and this is equal to the Laplace f of t, which is equal to all of this. Now, if we derive both sides by our d of s, so if we derive this by d of s and then derive everything inside of our integral by d of s, we are going to get that our f of s, d, and then ds is equal to, we have the integral 0 to infinity, f of t is a constant, so nothing is going to change. We are then going to have an e negative s of t. We take the derivative of this, and the derivative of e is just itself. But because of the chain rule, we have to take the derivative of the top, which is going to be a negative t. Then we have our dt. So this is going to be our equation. We can see that this t is in here, and there's other videos in the playlist for network analysis linked below the like button that explain this way more. But basically, we are going to multiply both sides by a negative 1. That way this becomes a positive, and this becomes a negative. So our t is equal to a negative d over ds. And we can kind of see this because t is the only thing that changes on this side, and what changes on the left side is that we have a negative d of s. So we can say that these are a causation of each other, so they equal each other. Now, for our problem though, it says that we have a t cubed. So because we have a t cubed here, we are going to have a t cubed here, meaning that this is cubed, meaning that we're going to take the derivative 3 times. So when we look back at our problem, we can move a 31 out. We can put this outside of a parentheses. So because it's just a constant, we don't need to deal with it now. We are going to substitute our t cubed for a negative d over ds. Remember, this is cubed. And then we're going to have this e negative 5t. Well, the e negative 5t, we are going to look in here like this. We can see we are going to substitute this in for the Laplace. We're going to have 1 over our s plus a. In this case, our a is a 5, so we're going to have s plus 5. This is going to be our equation. We just need to take the derivative of this. So taking the derivative of this, we are still going to have our 31 out front. We'll make it a negative 31. We'll just factor out the negative. And we are, instead of just taking the derivative of this using the quadratic equation, I'm going to say that we have an s plus 5 with a negative 1. That way it's a lot simpler to deal with when we're actually deriving. So we're still going to have this derivative out here because we have not derived it yet. So for the first derivation, we're going to have a negative 31, we are going to have a negative 1, and then we're going to have an s plus 5. For the second derivation, we are going to have 31, we are then, this should be a negative 2 actually. When we differentiate, we subtract 1 from the n up here, and then we bring n down up front. So this will be a negative 2, and then we're going to do the same thing for here, so we'll have negative 2 out here, we're going to have s plus 5, this will be a negative 3. We should include the d here because we haven't finished it yet, so it's going to be d over ds. We need to differentiate one more time, so the third time is going to give us a negative 62, and then we are going to have our negative 3 brought down, and then we're going to have our s plus 5, and then we're going to have a negative 4. So this is our entire derivation, and now we can just combine things. So if we combine things, we're going to have 62 times 3. This is going to give us 186. This is going to be divided by, and then we're going to have an s plus 5, and this is being raised to the 4th power. So if we look at our answer box, we'll have a 186 in front. We're going to have an s plus 5, just a 5 here, and then we have the 4 right here. So that's how you would go about solving for this quiz.